So system call, it provides an interface in between the user application program and the operating system, or we can call it as a kernel. So by using system call, here user mode, it can interact with the kernel mode. System calls that are used to interact or to perform the interaction in between the user mode and kernel mode. So different types of functions provided by the system calls are, by using the system calls, we can perform the process control management, we can perform the file management, then device management, information management, and the communication management. So these are the main functions which are performed by the system call. So here we can say that system calls that are the entry points for the kernel. Means by using the system calls, you can interact with the operating system, or by using the system call, you can request a service from the kernel. So normally the system calls that are written in the high level language or in the assembly level language. And these system calls we can directly use in the Linux operating system. So the first type of function which is performed by the system call is the process control management. So in the process control management, by using this system call, you can create a process or you can abort the process. You can load that process from the secondary memory into the from the secondary memory into the primary memory. After that, you can execute that process. If multiple processes are running in your computer system, then you can perform the wait operation. That is, if your processor it is holding one of the process, then other process it will be placed into the wait queue by using this process control management mechanism. After that, it will allocate the memory to the process which is running, and after that it will deallocate the memory of the process if it is no longer required it. So these are the different functions which are performed by the system calls which are written for the process control mechanism. Now for this we will take one of the example. So before that, now see, these are the some of the examples of the system calls which are written for the process control. So if you are using the Windows operating system, then in the Windows operating system you can create a process, you can exit from that process, or you can wait for that process. Now suppose here you want to exit from the Microsoft Word. So for that, what you will do, the file menu is available there. From that file menu you will choose the exit button. So you will click on that exit button, and after that you will come out from that you will come out from that Microsoft Word process. So by using these buttons only, direct keyboard keyword only, we can interact with the system calls. That is by using the open operation, open button. In the file menu, different types of buttons are available in the Microsoft Word or in any application. That is, you can create a new file. For that, new button is available. For opening the existing file, the open button is available. For closing it, the close button is available. Then for saving it, save and save as buttons are available. So these are the different application program interface by using which we can interact with the system calls. Okay, whereas in the Linux operating system we can use the direct system calls, for example fork, exit, and wait. So these are the different examples of the system calls which are used for the Linux operating system. So we'll take one of the example of this system call. So let us consider the fork system call which is used in the Linux operating system. Okay, so for this keyword, it is followed by opening and closing round bracket. So it is nothing but the function. So here actually, whenever we are using that keyword inside the program, then that time we are calling that fork system call directly. Now, what is the use of the fork system call? So by using the fork system call, here you can create a new process. Okay, so here let us consider that parent process is already running, and in that parent process, if you are calling the fork function, that time it will create the child process of that parent. Okay, so here it will create the child process, and after that, once the child process of that parent is created, then both the processes that will share the common address or common memory location. Okay, so here you can see that both the processes will execute. And again, one important thing is that let us consider that if you have created the parent process, and in that parent process, suppose you are calling the fork system call, that time already the parent process is already exists there, And after that, your parent process, it is calling the fork system call, and fork system call, it will create the child of the parent process. So here at a time, two processes are running in parallel, parent process and child process, and both the processes are sharing the common address. And after that, both the processes, they will execute the statements which are written after the fork system call. Now, how it actually run by the operating system? So for that, we will take this simple example of the C program. So in this C program, we are making the use of fork system call. Now, how this fork system call is accessed or how it is used by an operating system? So let us consider this program. In this program, the main function is written. So main function, it acts as a parent process over here. So main is the parent process, and inside that main function we are calling the fork function. So fork keyword, it is followed by opening and closing bracket. So we are calling the fork function inside the main function. So when you will execute this program, when you will compile this program, and after running this program, at first your operating system, it will create a parent process which is representing the main function. So parent process is created for the main function. Inside the main function, the fork function or fork system call is written. So when your compiler or when your operating system, it will execute the statement, that is fork function, which is written inside the main. After that, it will create the child process of the parent process, which is represented by the main function. So now two processes are running in parallel. One is the main process, which is representing the parent process, and another is the child process, which is created because of the fork system call. And after this, now two processes are running. Now both the processes that will execute the statements which are written after the fork system call. So in this main function, we are trying to print the statement, that is hello world. So that statement, it will get displayed on your computer screen, and then you are returning 0 there. So it will print the hello world two times. Why? Because once the child process is created, the parent process and child process, that will execute in parallel. So that will execute the statements which are written after the fork. So after the fork, we are trying to print hello world. So your main process, it will print that statement. After that, the child process will also print that statement. Okay. So this is the use of the system call, that how the processes are created by using the system calls of an operating system. Have you understood this? समझ में आया? Any doubt in this? Okay. So after that, so see, this is the output of this program. That is, it will print the hello world two times. After that, the next function which is performed by the system call R, that is function management. So in the function management, file management. So in the file management, we can create a file, we can delete a file, you can open that file and close that file after completing the operation. You can perform the read write operation, and you can find out the different attributes of the file. So again, in Windows operating system, you can create the file directly. That is, if you are using the Microsoft Word, then you can use there from the file menu, you can choose the keyword, that is, you can access the new keyword, and after that the new file, it will get created. Then you can open that, then you can perform the save operation, you can write into that. So all these operations we can directly perform by using the application program interface. So this inside the file menu, different APIs are written, that are called as API, that is new, then save as. So all these are the API by using which we can perform the different file management operation. But now if same operation you are performing in the open source operating system, then you can perform it by using the open, read, write, and close functions, or close. These are the different system calls of the Linux operating system. So you can perform this file input output management operation in the C program also. So we can write the C program for reading the file, and for writing data into that. So normally the file, it is saved into the secondary memory, that is into the hard disk. And when you want to perform some operations on that, means if you want to edit that file, then in that case you have to switch that file from the secondary memory into the primary memory. And once that file is loaded into the primary memory, then only you can perform different operations on that file. And these file management operations that are performed by using the system calls, So for that, here I will explain you the example of the Python programming. Okay, so now these file management operations that are written by using the Python programming language. So currently you are learning this Python language. So here let us consider that demo file.txt. This is one txt file or text file. It is already saved into the hard disk or into the secondary memory. And suppose now you want to write the program in Python, so that in your program you will access that file. That is, you will load that file from secondary memory into the primary memory, and you want to load that file for the reading purpose. Okay, so here see what is the statement written in the Python. So here we are writing f, it is equal to open. Open, it is nothing but the system call. So this system call, it is used to open the file. Okay, so it is used to open the file. Actually this open system call, it is transferring the file from secondary memory into the primary memory. So here we are directly accessing the system call. So open is one of the system call. After that, inside the bracket, we are passing the name of the file. So name of the file is demo file.txt, which is already created by you. And after that, R is written. R, it is nothing but the mode of that file in which you want to access that file. Means R means you want to open that file for read purpose. So that's why here we are writing there R. Okay, so here by using the open system call, that file, it is loaded from secondary memory into the primary memory for reading purpose. And after executing this statement, your Python interpreter, it will create an object which is representing that file demo file.txt, and that object, it will get saved into the variable, and name of that variable is f. So that f, it is also called as file pointer. By using that file pointer, you can manipulate or you can perform different operations on that file. Okay, so in very simple language, here what is the meaning of this file handler, or what is the meaning of this variable f? So let us consider the example of remote. Now suppose here you want to turn on your TV or turn off your TV, or if you want to increase the volume or decrease the volume of your TV, or if you want to change the change the channels of the TV, then you can access your TV by using the remote. Okay, so remote, it is nothing but the file handler of your computer or of your TV. So here this f, it is nothing but the remote of the file. By using that remote, we can perform different operations on that file. So in the computer language, we are calling that f as a file handler, by using which you are manipulating that file. So it is nothing but the remote of that particular file. Now here that object, it is saved into the variable f. Now you can read it by using the read system call. So printf f dot read. So if you are, when you will execute this program in the Python, then here it will display that file in front of you, and you can read that file. Okay, so once that file, it is open into the read mode, then after that you have to close that file. Okay, so because whenever you are reading that file, that time that file, it is transferred from secondary memory into the primary memory, and once the reading operation is over, you have to again transfer that file from primary memory into the secondary memory. So it is necessary to perform the close operation. So it will deallocate all the sources which are already assigned to that file. Okay, but now here, before after performing the read operation, suppose you want to append data into that. So for appending data into that, we can perform this operation, that is f, it is equal to open. So open the file, name of that file is demo file2.txt, and you are opening that file for the writing purpose. So here a, it is representing the append operation, so by using which you are appending the data at the end of the file. So once you will execute this program, your program or your operating system or compiler, it will add the data which is written by the user at the end of the file. Suppose 10 lines are already there in your file. So after the 10th line it will add this statement, that is now the file has more content. So this file it is this line it is added at the end of the file, and once the writing operation is over, once the appending operation is over, then you can close that file. Okay, so this is the read and write operation. Now here you can open the file in the read mode, or you can open the file in the append mode. Okay, now suppose now if you are using the W mode, so let us consider this one, that is f it is equal to open file name.txt, and here we are opening that file into the write mode. So by using this W mode, you are able to add some data into the file, and by using the append mode also you are able to add data into the file. But now what is the difference in between the append mode and the write mode? So in the append mode, the data is added at the end of the file, that is whatever data is present into the file that remains as it is, and the remaining data it is added at the end of the file. But when you open the file into the W mode, that time it will delete the previous data of the file, and that data it is overwritten by the new data. Means here whatever, suppose 10 lines are there which are already present in your demo file.txt, so all that 10 lines that are overwritten by this new line, that is I have deleted the content. Okay, and after we are performing the closing operation. So in this example you can observe that here we are using the we are using the open system call, then we are using the write system call. After that here we're using this open system call by using the different modes, for example read mode, append mode, and write mode. Okay, so these system calls in the Windows operating system, these system calls are called as application program interface, whereas in Linux operating system we can directly use that system call. And all the examples of the system calls which are used in the Linux operating system, so that examples we will see at the time of practical. So that is your first practical, that is to study the different system calls of the Linux operating system. For example, fork system call, wait system call, execute system call. So all these system call we will run in the practical. Okay. Any doubt in this? Have you understood this? Yes. Have you understood? Okay. So now I have given you two examples, that is fork system call and how to perform the read write operations in the Windows operating system. After that, the different types of operations which are performed by the system calls are device management. So by using device management here, you can interact with the different device drivers, that is different device drivers which are available for the keyboard, then for mouse, then for printer or for scanner. So suppose here you want to take a printout, and if you have attached the printer to your computer system, then that time your operating system it will execute the system call which is associated with the device driver of the printer. So this can be done by using the device management function. So these are the different system calls which are used for the device management. For example, read data from the keyboard or display the data onto the monitor. So it is done by using the write operation. So these are the device management functions. After that, the next function which is performed by the system call is information maintenance. So information maintenance means here by using this system call, you can find out the different features or different characteristics of the file that or characteristics of the processes which are running on your computer. That is, you can find out the process ID, that is process identification number. It is assigned by an operating system to each process. So you can find out that process ID. After that, you can find out the current time and date which is recorded on your computer system. So different types of process and device attributes that are obtained by using the system calls which are used for the information maintenance. After that, the system calls that are also used for the communication in between the two PCs. If the two PCs are connected in a LAN, if that are present in a network, or if that are placed at different geographical place, then that time you can perform the communication in between these two systems or different systems by using the communication system calls.